In this problem, it says the ratio of the lateral surface areas of two similar cones is 20:9. The ratio of their volumes is k to 1. We want to determine the value of k expressed as a decimal rounded to the nearest thousandth. So we have one cone over here. We've got the height, and we've got the radius. Then we've got a similar cone. And both the height and the radius are multiplied by some number. Let's just call it a. All right. Now the formula for finding the lateral area of a cone is pi r times the square root of h squared plus r squared. So for this one, it's going to be pi times ar times the square root of ah squared plus ar squared. Now out here, we can expand these. We have a squared h squared plus a squared r squared. Now both of these have an a squared in common. So when we factor that out, what happens is we get h squared plus r squared, and we can take that a out. So we have a squared times r times the square root of h squared plus r squared. So when we take the ratio of this to this, we have pi a squared r times the square root of h squared plus r squared all over pi r square root of h squared plus r squared. What happens is that, first of all, this is 20/9. And so everything cancels except a. A squared equals 20/9. So that means a equals square root of 20/3. And that simplifies to 2 square root of 5/3. All right. So now what we want to do is we want to compare the volumes. So the volume of the first cone is 1/3 pi r squared times h. The volume of the second cone is 1/3 pi. Now instead of r, we're going to put ar squared times ah. Now if we square this, we get a squared r squared times ah. So we have a cubed times r squared h, like that. So really the only difference between this formula and this formula is this right here, a cubed. So a cubed is the multiple of the volume. So really a cubed is k, what we're looking for. And so to do that, we're just going to take 2 square root of 5/3, raise it to the third power. Now since it has to be a decimal, I'm not going to simplify that. Just go ahead, 2 times square root of 5/3, and raise it to the third power. And so to the nearest thousandth, it's 3.313 is our answer. Now, I want to point out a slightly quicker way you could do this, and that is the areas are in this ratio. So that means the lengths are in a ratio of square root of 20 to square root of 9. Because all you do is say, well, area is a square unit, length is not. So you take the square root. The volume is a cubic unit. So volume is just going to be this, square root of 20 cubed to square root of 9 cubed. That's going to be the ratio. And so if I calculate that, square root of 20 cubed divided by square root of 9 cubed, we end up with the same answer. So those are two ways to find our answer, and we're done.